For this next example, we're going to determine the extrema and the points of inflection for the function over the interval 0 to 2 pi. So our trig ones will always be over this interval. Okay. So what we're going to do is this time we don't have to write the increasing, decreasing intervals. We're just going to write the coordinates of the max and min and the point of inflection. So my first derivative of cosine, negative sine, derivative of 3x is 3. My second derivative, the derivative of sine is cosine, so the sign doesn't change. So this is just going to be negative cosine. The derivative of 3 is just 0. Okay. Then I'm going to set these equal to 0 and solve. So I'm going to move the sine of x over. And I'll get sine equals 3. Okay, well this number is too big for a sine value. Remember, sine is opposite over hypotenuse. So this is 3 over 1. So the hypotenuse is smaller than the opposite side. Well, that's not possible. So we're not going to get any answers from this one. Okay, so what we need to do is we still need to make our number line. Okay, and this time I'm just going to cut it off at 0 and 2 pi. So I didn't get any actual values to put on the number line, but I still need to test this entire interval. So I can take any number that I want from 0 to 2 pi and plug it in here. Okay. So I'm just going to do pi, just because it's halfway between. But you could do 0, you could do pi over 2, you could do pi, you could do 3 pi over 2. Okay. So if I do negative sine of pi plus 3. Okay, so this is, I'm just seeing if the first derivative is going to be positive or negative. Well, sine of pi is 0. Remember, sine is the y value. So that'll be 0 plus 3, which is a positive number. So that means this function is increasing over this entire interval. Now I'm going to go solve my second derivative. So that's just going to give me cosine of x is 0. Okay. And remember, cosine goes with x, so we're looking for where x is 0, which would be the two angles on the y-axis. Okay. So that is going to give me pi over 2 and 3 pi over 2. Okay, so I'm still cutting off my number line at 0 and pi. Okay, but I can plug them in here since I didn't actually get these values. So I can use those numbers to test the intervals if I want to. Okay. So for this one, I need to plug in something less than pi over 2. I'm just going to use 0, which is fine. As long as you didn't get it as one of your answers here, you can use this number. So if I plug in 0 to the second derivative, that would be negative cosine of 0. Well, 0 is over here. Cosine goes with x, which is 1. So that's going to give me negative 1. So that's going to be a negative value here. Then if I check something between these two, so if I check pi, I would do negative cosine of pi. Well, cosine of pi is negative 1. So that's a negative, negative 1, which is positive 1. So that interval will be positive. And then I'm just going to check 2 pi, because 2 pi is in the same place as 0. So whatever I get for 0 is going to be the same thing that I get for 2 pi as far as positive and negative is concerned. So this part I know is also going to be negative. Okay. So for our extrema, we don't have any. It's increasing the entire time. So for our relative min and our relative max, since it never changes from increasing to decreasing, that means there isn't any. Okay. Then for my points of inflection, that's where the concavity changes. So that's going to be at pi over 2 and at 3 pi over 2. Okay, I know this doesn't say write the coordinates, but since we're going to need these points to graph it, I'm just going to go ahead and figure out the coordinates. So you only have to do the ordered pair when it says write the coordinates, but I'm just going to find this for some extra practice. Okay, so to find the coordinates, you go back to the original function. So to find this value, I'm going to do y equals cosine of pi over 2 plus 3 times pi over 2. So cosine of pi over 2, cosine goes with x, so that's going to be 0. This part right here is going to be 3 pi over 2. So that'll end up making my y value for the first point of inflection, 3 pi over 2. Then I'm going to plug in 3 pi over 2 for x to get the second y value for the point of inflection. So cosine of 3 pi over 2, that again is going to be 0. 3 times 3 pi over 2, that's 3 over 1. So that's just going to give me 9 pi over 2. And those will be my 2 points of inflection. Sometimes when you're evaluating this number won't be a 0, it'll be like a 1. If that was the case, you would just leave it as 1 plus 9 pi over 2. So if you get a value with pi in it and then a regular number, you just leave them separated with the plus sign.